Okay, so let's do the 47 for this these things right here. I'm not supposed to have that one. Alright, so I need to calculate the OH concentration and pH for and percent ionization for 0.2 molar H3 NH3 solution. So let's create the rice table, right? Again, that's always the case here. So R, rice, the product, the reactant, and then product is some other color, right? Okay. So reactant and product is given like this, right? And then initial concentration of the NH3 is that, and then I'm just going to put the 0 and 0 here. And then the change, it's going to be X right here, 0.001, magic numbers that I always use. Negative that, and then that's equal to positive that, right? Same stuff here, equal positive that, right? Good. Then at the current concentration is the plus this, and then current concentration for that is this plus that, right? I'm gonna repeat the same stuff here. So if I check that, yep, right? So I got the rice table. Now I'm going to calculate Q here. It is Q because I don't know the actual value of X right now. So product over reactant, so that times that divided by this, right? This is a Q for the association reaction, right? Base association constant. So from the table, you can actually get the value of that to be 9.25, which is that one right here. You can actually use these things too if you want to, but 9.25 seems simple enough. Then what is the KB here? PKB, sorry, PKB is 14 minus this guy, it's 4.75, and then what is the KB here? KB, right here. The reason why I'm using KB instead of Ka is because I have this reaction is the base association constant, right? So the Kb right here is equal to 10 to the power of negative pKb, right? So it's that one. So I'm gonna change this one to the value of that guy by changing this one, right? The same stuff. So go to data, solver. I'm gonna change this one to the value of the 1.77 e to the negative 5. Sorry, then I couldn't register by changing X. And then this one right here unchecked. Now, other things that I need to check, of course, that I should probably check this one right here. 1E20, that's good. And then solve. Good, I found solution, which is this guy right here, right? Now, let's try to do the very first thing, the calculation of the OH something concentration. That's done. That's this one. And what is the pH here? If I know the OH concentration, then pH, pH, yeah, pH. So let's just do the POH here. I'm going to go with the POH. POH is equal to minus log of that guy, right? So the POH, this one, the pH is equal to 14 minus that guy, and percent ionization. So I'm going to put all of these guys in a red. Percent ionization is you realize that this one right here and that one right there is a total. So just think of these things as nitrogen here, right? The number of nitrogen, you started out at 0.2, and if I add these two numbers, let's just write out these two numbers, this plus this, right? It's going to add up to the same numbers. The reason why that's the case is because number of N atoms is not going to change, right? So B and BH plus is same, right? Same as B, right? Same as B at the initial, right? So it's a conservation of mass sort of things, right? Then how much of this is going to dissociate, which is this divided by that. So the percent ionizations, percent ionization is equal to what's being dissociated to the total. You can actually use this one just because. So that's that. Oh, and probably multiply by 100 to get the percent. So that's pretty much all there is to it for this problem.